So you need to, but however, okay, so my example is kind of too good. Alright, so let me refine it a little bit. Well, make it worse a little bit. Okay, let me try to draw this. Okay, and then alright, so for example, this will be the pixel that you need to process. This, and maybe this, and this. So what I'm trying to say is that if your epipolar line is actually, it doesn't really, it covers the pixel like randomly, then in this case, it's actually difficult to find the corresponding pixels that you need to search with. And not to mention, if you open a certain buffer region, it's also difficult to search for other pixels, right? Performance issue, actually, is a processing performance issue. So in this case, we actually can solve this problem with the auto-replication process as well. So if you still remember the auto-replication process, the first thing that we need to do is to open the blank image, auto image. And that blank auto image is designed by ourselves. So what's the size of each pixel, and what's the you can say the rotation of each angle. So it doesn't need to be exactly the same as it doesn't need to fit for example, the same x-axis or y-axis. We can choose the x-axis and y-axis, and usually we will choose the x-axis as the and we will choose the x-axis and to be parallel to the epipolar line. We will choose the x-axis that is parallel to the epipolar line. So which indicates that for the also ratified image, your epipolar line will be over here. Will be over here. So all the pixels that on the same x-axis, with the same, you can say, along the same x-axis, they have the same epipolar line. They have the same epipolar line. So, of course, you have master image and slave image. Master image and slave image. And like I said, because the author image is created by you, is defined by you. So these coordinates are exactly the same. So what you can do, and if there's the scope of the image, if they are also the same, then for example, like right now you are taking a look at the this. For example, y-axis as I don't know, randomly 55. You have the line 55, and this line 55 for some certain pixel, if that's a feature. For example, this is a feature point. And if right now you want to find the matched point for this pixel, then where you are going to search for is actually the line over here. Or you can also create a certain buffer region like this. And the creation of the buffer region is also very simple because they are just the integer values. Yeah, they are just the integer values of the pixels, the x and y pixels. So it will be very easy to perform the moving window, you can say. Right, so the performance will be much better than having the epipolar line as on the image like this, and it will be difficult to process. Write it down a little bit more. And this is, yeah, it is, people will say you are constructing the epipolar geometry. Right. When people say that they are constructing the epipolar geometry, it's epipolar geometry. If people say that they are constructing or they are using the epipolar geometry, that indicates they already do some pre-processing to create the two images from the master image and slave image, and to become something like this. So all the x-axis coordinates they fit with the same epipolar line. And so the procedure will be, the procedure of finding the conjugate points will be more efficient. So if they say they have constructed the epipolar geometry, then that indicates they already prepared this. They prepared this. Okay? And that solved, and that indicates that it's solved. They already solved the scale differences issue, and also perspective differences issue, and also they make the x-axis along the epipolar line, so the procedure is more efficient. So basically, that indicates those terms. That statement or that sentence indicates that. Okay. Okay. So, and earlier when I say sometimes when you import some images to the software, to some photogrammetry software, and you will see that it's like running something. Even without you didn't actually to do anything, you just import the data, and sometimes you see that there's a procedure is still running and running, and one possibility is it is constructing the image pyramid, and the other possibility is that it is constructing the epipolar geometry. If you import the stereo pairs, if you import the stereo pair, then some of the software they will automatically construct the epipolar geometry, okay? Because they anticipate that if you import the stereo pair, then later on you are going to do some image matching or some image matching work, okay? So that's the case. Okay. Any question? Yeah. No question? Is it? I don't know. Is it too much information? It seems like it's a little bit too much information for you to like absorb. I'll let you guys think about it for a few seconds. Then, because we still have time, so we can move on to other topics. Well, some extended topic. Yeah, we still haven't finished everything with the image matching. So, but for now, it's like most of the important process has been introduced for the image matching. So. Yeah. Any question? Any question? Any parts that you don't really understand? All right. If not, let's move on. Yes. All right. So the next thing that we are going to talk about is, let's assume here we have a building. We have a building over here, and supposedly this, for example, the target is, for example, the edge of the building somewhere over here, and then we can find this P point, and what we want to do is to find the corresponding P point here. So when we want to do it, you will find one small problem, which is, I will erase this part. The building could be like this. It could be like this. The same building. And then, for example, this point, maybe is the edge over here. Let's just assume this is the point that we are talking about. This is the point, and this is the point. And, right, can you guys understand what I'm drawing? I'm trying to draw. So this is from the master image. This is from the slave image. This is from the slave image. Right, so master image and slave image. So right now we have a feature point over here. Let's assume just over here on the edge of the building. So if we are going to perform the image matching to find it, and right now, even if we have constructed the epipolar geometry, even if we have constructed that, and so as you can see, it's on the same line, it's on the same x-axis. Is there any problem if we, is there any problem when we perform the calculation of similarity over here? When we try to perform the match, is there any problem? First of all, can you guys understand what I'm doing? This is a building, and this is a rooftop, and yeah, okay. Hopefully you guys. Yeah. Okay, so when we perform the matching, any problem? You? Any thoughts?
I'm thinking.
You're thinking, okay. You, any thoughts? Right. Try to draw it. Okay, so originally we know that we still need to have the target window and moving window, right? So maybe we will have a target window over here and a moving window over here. All right. So that's the scenario. That's the scenario. So any problem
characteristic of two tele window is different. One is like related with the rooftop and the buildings. The other one is maybe rooftop with the ground. So it will mistake.
Okay. So, yes, that's the problem. As you can see, here, this half is the rooftop. This half is the rooftop. So, rooftop to rooftop should be fine. They have high correlation. But however, as you can see, another half, this may be ground. This may be the side of the building. So the correlation between these two, this half, actually will be low. Then in this case, if you calculate the similarity between these two windows, maybe the similarity is not so high, even if it is the correct conjugate point. So the problem is from the relief displacement. The problem is from the relief displacement in this case. Okay, so that's the problem. And if we can see the problem, then any solution that we can try to overcome this. Is there any solution that we can design to overcome this? Try to think about that. Try to think about that. Any solution that we can design to overcome this problem. There's still a good, you can say, a half of good match, which is the rooftop, right? Is there any way we can adjust the window